Ciao. Well, that's the way we say hello in Italy. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, here we are dealing with permutations and combinations. Earlier in the last lecture, we have looked up how we can talk about the principle of counting, that is the principle of multiplication, to be applied when we have to decide about how many cases are possible for a specific instance. Now here, children, if suppose we are to talk about the number of permutations which are required from a given number of cases, then we talk about it to be by a notation. For that matter, let's say now we have some n objects, out of which we are to choose say some say r objects, right, to be forming permutations or arrangements. Then we write that something like this, that is n p r. Remember here, n is the superfix and r is the suffix. The number which is there in the superfix is always larger than the number which is there in the suffix, and the number which is there in the superfix tells about the total number of entities that you have at hand, and r, that is the number in the suffix, tells you about the number of entities which are to be taken, with which you will be making permutations or arrangements, right? For that matter, let us now discuss that we have say some 100 p12, right, which has to be found out. So now, children, if we talk about this npr, right, this corresponds to 100 p12. So as I told you, the number which is there in the superfix is always larger than the number which is there in the suffix, right? Remember that the numbers which are there as n and r are both from the set of natural numbers, and now 100 is the total number of entities or the total number of objects which are there, and at a time 12 will be chosen so that you can form the number of arrangements or you will form the number of permutations, right? So this is how npr can be written in terms of numbers. Now let us try and understand how you can find out the value of this. For that matter, if you talk about npr, this will be given by factorial n divided by n minus r factorial, right? I'm sure you people must have studied factorial. For that matter, if you haven't studied factorial, I'll quickly give you an idea about what factorial is. Let's say we have factorial 7, so that will then be written as 7 multiplied by the natural number which is just less than it, multiplied by the natural number which is just less than it, that is 5, and all of this, children, is going to go up to 1, which is the first natural number. So this is factorial 7. And similarly, I'm sure if you want to find out the factorial of say 73, then you will write this as 73 further multiplied with 72 further multiplied with 71, and all of that will go up to the first natural number, which is 1, right? So this is how, children, you find out the factorial of a number. And now, as we have this case, so we will discuss the case here. First, let's quickly revise npr. When we talk about npr, then npr is the number of permutations when we are choosing r different objects out of n different objects to form different arrangements, right? Remember, when we talk about arrangements, order becomes important. Like say you talk about two digits which have been taken to form a specific number. Let there be 1 and 2. So here, if say you talk about 1 2 to be a number, order is important, and that is why 2 1 will give you another number, right? This is how, order being important, we talk about such type of objects being chosen where order is important are known as arrangements or permutations, right? Always remember that when we talk about permutations, order is something which is very important. If the order changes, the permutation or the arrangement changes, right? So after this, children, we talked about npr, which is the notation, or which is the way by means of which, or which is the formula by means of which you can find out the number of permutations, is going to be factorial n, that is factorial of the number in the superfix, divided by the factorial of the number which is the difference of the numbers in the superfix and the suffix, right? Now here, children, we have an example like say we have 100p12 which is to be found out. Now in order to find it out, what we are going to do is first you will write the factorial of the number which is there in the superfix, which is 100, and in the denominator you will write the factorial of the number which is the difference of the numbers in the superfix and the suffix, and here we have 100 minus 12. Now in the next step, children, this is going to become equal to 100, and if you talk about the denominator, 2 and 8 is 10, and then we have 2 and 8 is 10, so we have 88 factorial which will be there in the denominator. This is a tedious task to calculate it, so you have to learn some ways by means of which you can do the calculation easily, or obviously there are calculators for you people to be able to calculate, although calculators are only allowed in the ISC board, and the CBSE and the other boards do not allow calculators. So for them, that's why the questions are such that you don't have to calculate much, right? And if you have to, then you will be using some simple methods which in times to come I will teach you, which can help you to find out the value of these permutation notations in a very simple way. So now, children, all that I told you, I'm going to quickly revise with you people so that you don't miss it out. Now, when we talk about permutations, you always have to remember that order is something which is very important, and permutations in some language of a sum can also be given to you as arrangements which are required, right? So either you talk about permutations, and another synonym of it is arrangements, and you always remember that order is something which is very important. For that matter, I told you if you choose two digits 1 and 2 to form two numbers, then 1 2 is a different number and 2 1 is a different number, and that is where the order becomes important, and that is where we talk about arrangements or permutations, right? When the order is not important, in times to come we'll be studying about combinations, and there we choose a group, or we talk about a selection, right, that gives us order to be non-significant. So when you choose, then order becomes unimportant, and that then is known as a combination. Okay, now children, if we have n entities out of which at a time r entities are being taken to form some arrangements or permutations, then we represent it by NPR, that is, this is the formula, and this then is given by factorial n divided by factorial of n minus r. Now children, here I discussed with you people what factorial is. For that matter, if say you talk about factorial 7, we can write it to be 7 into 6 into 5, and all of that continues up to 1, right? That means we write the first factorial, first natural number, right, and then we multiply it with the natural number which is next to it and just less than it. Then we multiply it with the next natural number which is just less than it, and all of this continues up to the first natural number. For that matter, I gave you another example that if we want to find out factorial 73, that will come out to be 73 into 72 into 71, and all of that is going to continue up to 1. Now children, we have an example, let's say 100p12. So if you want to find this out, then like we had the formula here, we'll have the factorial of the number which is there in the superfix, that is factorial 100, divided by the difference of the numbers in the superfix and the suffix, that is factorial of 100 minus 12. Now 100 minus 12 becomes equal to 88, so the ratio of both of these will then give you the factorial, the notation of permutation, or the answer for the number of ways that you can arrange 12 entities which have been taken at a time from 100 objects. Right now children, next we will be discussing certain sums on this notation so that you can be perfectly clear how to handle this notation. So the first question that I have for you people is something like this. Quickly give it a try, after which I'll be discussing the sum. Okay, I'm sure you must be jumping up with joy as you see the sum is very simple. Yeah, the first sum that I normally give you is pretty simple so that it brings in some confidence in you, so that in times to come we can do higher order sums. So here children, when we talk about 10 p3, then this is going to become equal to 10 factorial, which is going to be divided by 10 minus 3 factorial as we did it in earlier. Now for the children, this is going to become equal to factorial 10 divided by factorial 7, right? And now children, the way that we can write this is 10 into 9 into 8, right? into factorial 7, right, which is to be divided by factorial 7. Now you must be wondering that how did this factorial 7 come when the others were just numbers. So here I'll tell you that if you multiply factorial 7 with 8, obviously this will give you factorial 8. And further, if you talk about multiplying factorial 7 with 8 and with 9, so that will then give you factorial 9. And similarly, if you also multiply it with 10, so that will then give you factorial 10, right? Because if you talk about writing factorial 10, then factorial 10 is actually what? It is 10 into 9 into 8 into 7, and all of that, children, continues up to 1, right? So if we talk about these numbers, then these numbers are actually your factorial 7. And if further multiplied with 8, then that will give you factorial 8. And then further, if it is also multiplied with 9, it will then become equal to factorial 9, and so on it will continue. And that is the reason why, as we have the factorial of 10, we can write it as 10 into 9 into 8 into factorial 7. Now children, you get to see that factorial 7 will get cancelled from the numerator and from the denominator, and thus finally you will get 10 into 9 into 8, which can now be multiplied as 8 into 9 is 72 into 10 will become equal to 720, which will then become the value of 10p3, right? Now children, I'll just quickly discuss this. Here in the question we've been given find 10p3. So if you talk about 10p3, here we have factorial of the superfix divided by the factorial of the difference of the superfix and the suffix, that is 10 minus 3 factorial. Now 10 minus 3 is 7, so we have 7 factorial in the denominator. Then children, if you talk about this factorial 10, we can write it as 10 into 9 into 8 multiplied by factorial 7. As if you talk about factorial 10, that can actually be written as 10 into 9 into 8, and all of that continues up to 1. So if you consider the numbers from 7 into 6 and so on up to 1, this is actually factorial 7 with which these numbers can be multiplied. And if you multiply factorial 7 with 8, you will actually get factorial 8. And further, if factorial 8 is multiplied with 9, you will get factorial 9, and all of that continues. And that is the reason why we have written this factorial 10 as 10 into 9 into 8 into factorial 7. Now factorial 7 matches exactly with factorial 7 in the denominator, so both of these get cancelled and you're just left out with 10 into 9 into 8, which will become equal to 720, which will become your final answer. Are all of you people clear? For sure? That's good. Okay, now children, after this we'll be discussing the next sum, which goes something like this. Quickly give it a try, after which I'll be discussing the sum with you people. Okay children, now let's discuss the sum. Here in the question you've been given to prove 10p3 to be equal to 9p3 plus 3 times of 9p2. So here what we do in this question is we now first break up what we have in the terms of the notation formula. That is 10p3 can be written as 10 factorial, which is going to be divided by 10 minus 3 factorial, and this further is going to be equal to 9 factorial, which is going to be divided by 9 minus 3 factorial, and to that is going to be added here 3 times of 9 factorial divided by 9 minus 2 factorial. Right now here children, what we can do is we can write the left hand side as factorial 10, and in the denominator we have factorial 7, and in the right hand side now children we have factorial 9, which is divided by 9 minus 3, that is factorial 6, and to that children is added 3 times of factorial 9 divided by factorial 7. So here there are certain common things which can be taken outside, that is from the numerator you can take factorial 9 outside, right? Rather, for that matter, I will do one more step so that we can take maximum out. So here in the second term you will have plus 3 times of factorial 9 divided by 7 times of factorial 6, like we did it in the last sum. Now here we can take more common outside. So if we take factorial 9 upon factorial 6 common outside, we will be left out with 1 in the first term, and in the second term we'll be left out with 3 upon 7. Now children, on solving this will give us factorial 9 divided by factorial 6, right? And then if we take the LCM, we will get it to be 7 plus 3, right, divided by 7. And now children, in the next step what's going to happen is we will now have this to be factorial 9 upon factorial 6, which is then going to be multiplied by 10 upon 7. Now as you know that factorial 9, when it is going to be multiplied with 10, is going to become equal to factorial 10, and similarly when 7 gets multiplied with factorial 6, it will become equal to factorial 7. And now if you match with what you have on the left hand side, it matches exactly. So as such, factorial 10 upon factorial 7 is the same as factorial 10 upon factorial 7. Therefore this stands to be proved. So now children, I'll just quickly discuss this all over. In the question, you've been given to prove 10p3 to be equal to 9p3 plus 3 times of 9p2. Now in order to prove this, what we do is we write this to be factorial 10 divided by 10 minus 3 factorial, and on the right hand side we have 9 factorial divided by 9 minus 3 factorial, right? As if you remember that when we talk about NPR, it is actually equal to n factorial divided by n minus r factorial. That is how we can do this, right? So now for the second term on the right hand side, we have plus 3 times of factorial 9 divided by factorial of 9 minus 2, that is the difference of the superfix and the suffix factorial. Now here we solve this out. So on the left hand side we have factorial 10 divided by factorial 7, and on the right hand side, children, we have factorial 9 divided by factorial 6 plus 3 times of factorial 9 divided by factorial 7. Now here next what we can do is we can write this as factorial 9 divided by 7 times of factorial 6, because if you talk about factorial 7, then factorial 7 can be written as 7 into 6 into 5, and all of that continues up to 1. Now further, if you talk about this bracket, this is actually factorial 6. So factorial 6 when multiplied with 7 will give you factorial 7, and that is how here we have factorial 7, which can be written as 7 times of factorial 6. That is so that we can take maximum common outside. Now from the numerator we can take factorial 9 common, and from the denominator we can take factorial 6 common outside, and now inside we'll be left out with 1 in the first term and with 3 upon 7 in the second term. Further, we can take an LCM. The LCM will become equal to 7. Then we will have 7 plus 3, which is 10 upon 7. Now when 10 gets multiplied with factorial 9, it will become equal to factorial 10, and when 7 gets multiplied with factorial 6, it will become equal to factorial 7, and that is exactly what we had on the left hand side. Therefore this stands to be proved. So is everybody clear about this? For sure. Ronak? Good. Now children, after this we will be discussing the next sum, which goes something like this. Quickly give it a try. Okay, now children, let's discuss the sum. In the question you've been given to prove NPR, which is equal to n minus r plus 1 times of NPR minus 1, right? Now in order to prove this, first we talk about the permutation notation. That is, when we have NPR, then that is given by n factorial divided by factorial of n minus r, right? Now children, using this notation, now if we talk about the left hand side, the left hand side can be written as factorial n, which is to be divided by factorial of n minus r. Now if you talk about the right hand side, it will then become equal to n minus r plus 1, which is to be multiplied with npr minus 1, and that children can be written as factorial n divided by n minus r minus 1 factorial. Here this horizontal line is actually the horizontal bracket, as here we had to subtract from the superfix the suffix, right? Now children, in the next step what we can do is, in the left hand side there is nothing much to do, and in the right hand side we have n minus r minus 1. We can write this, right, so that this becomes equal to, on multiplication with the minus sign, n minus r plus 1, as is there in this number, right? Now children, here you talk about the numerator to be factorial n, and in the denominator, if you talk about this n minus r minus 1, this factorial can be written in a different way that now we are going to discuss. Let's say now if we talk about here some factorial 6, I'm sure you're going to tell me that we can write this as factorial of, say, some 7 minus 1, right? Now just tell me, if say we talk about some factorial of 7 minus 2, out of both of these, which is going to be the larger one, right? I'm sure you will calculate this and tell me that factorial of 7 minus 1 is factorial 6, and if you talk about factorial of 7 minus 2, then that will become equal to factorial of 5. Or in other words, we can say that this is factorial of 5. However, the left hand side, or the one which is above, is actually factorial 6. So as such, you find that the one which is above is larger and the one which is below is lesser. Or in other words, we can say that factorial of 7 minus 1, right, is greater than factorial of 7 minus 2. Now here, children, this actually gives you an idea about a concept, that is, if from a number you subtract a lesser number and you find the factorial of it, then it will be larger. And if from a number, rather from the same number, if you subtract a larger number and if you find out the factorial of it, then that is going to be lesser, right? So on subtracting lesser, the number and its factorial is going to be larger, and on subtracting greater, the number will become lesser and its factorial will also become lesser, right? So this is the concept that we're going to use here next. So now, children, if we talk about, say, some factorial of n minus r minus 1, then I'm sure you will tell me here that if we talk about this, we can write this as n minus r minus 1, which is the largest number here. And here then we will be talking about the next lesser number, right? So the next lesser number, as we just saw here, will be such that if we increase this by 1, we will then get the next larger number, right? So as such, it should be how much? It thus should be n minus r, right? And further then, if you talk about the next number, obviously it should be a number which should be now lesser, or in other words, it will become equal to n minus r plus 1, right? Because r plus 1 is a larger number, and thus if subtracted from n, it will become a lesser number, and all of that, children, will continue up to 1, right? For that matter, this can also be understood, say, something like this. If, say, you talk about 7 factorial, that can be written as factorial 7, and further you multiply this, not multiply this, but you can write this to be equal to 7, and further you can multiply this by a number which is just less than it in the set of natural numbers, that is not factorial again, that is 7 minus 1. And then further you multiply this with a number which is just less than it, that is 7 minus 2. Right? Then you multiply this with a number which is just less than it, that is 7 minus 3, and all of this continues up to 1. So here, what are we doing? The first number is 7, right? Or in other words, it can be said to be 7 minus 0. And if you talk about the next number, we are subtracting 1, right? If you talk about the next number, we are subtracting 2. If you talk about the next number, we are subtracting 3. So when we are subtracting larger numbers from the number, then the number is becoming the next less number, the next less number, and so on. Similarly, when we had factorial of n minus r minus 1, n minus r minus 1 was actually the largest number, right? Now here, if you talk about this number, right, this will be the least, right? That is r minus 1. When we write the next larger number by adding 1 to it, right, like we did here, we had 1 here, we added 1 to it, what we got 2. So when we add to r minus 1 1, so we will get r, right? And then further to r, if we add 1 more, we will get r plus 1. And then further, if we add to r plus 1 more, it will become n minus times of r plus 2, and then we will get the next lesser natural number, and so on, right? And this is the reason why here what we're going to do is we will now be writing this factorial of n minus times of r minus 1 written as n minus r minus 1. Now here the next lesser number, which is going to be n minus r, right? Because here we will now be having the number which is just less in the natural number series by adding 1 to the number which has been subtracted, like r minus 1. Now next we will talk about the next number, right, and so on, and the product of all of this is going to go up to where? Up to 1. So obviously if you talk about this number which is from n minus r going on up to 1, this must be factorial of n minus r. So this is what we're going to write in the next step, that is we have n minus r minus 1, right, times of factorial n, which is going to be divided by n minus r minus 1 times of factorial of n minus r. Right now, children, we find that n minus times of r minus 1 is common to the numerator and in the denominator and in multiplication, so it will get cancelled. Now if you match with what you have in the left hand side, we had factorial n which is divided by n minus r factorial, and that is exactly the same as we have in the right hand side. As such, now we can say that this sum stands proved. So I'll just quickly discuss this once more, children. In the question, you've been given to prove NPR to be equal to n minus r plus 1 times of NPR minus 1. Now here what you do is we use the notation of permutation, that is NPR is equal to factorial of the superfix divided by the factorial of the difference of the superfix and the suffix, right, in the left hand side as well as in the right hand side. Now here, children, we have in the left hand side NPR, so that will become factorial of n divided by factorial of n minus r. And on the right hand side we have n minus r plus 1, which is a number which can be written as it is, times of, we now have n factorial divided by n minus times of r minus 1 factorial. Now children, if we talk about this n minus r plus 1, we can write this as n minus times of r minus 1. Why? Because if you multiply this minus sign within, it will become n minus r plus 1, right, just as the same as above, right, and this matches with whose factorial has been found out. Now children, here we directly come to this. Now if we talk about factorial 6, obviously it can be written as factorial of 7 minus 1. So factorial of 7 minus 1 is just the same as factorial 6. Similarly, if you talk about factorial of 7 minus 2, then that will be the factorial of 5. So here you get to see one thing, that is, if from a number you subtract a larger number, right, then the number and its factorial become lesser, all right, and that is the reason why factorial 6 is greater and factorial 5 is larger, right. Now next, children, if we talk about that with respect to some numbers which are variables like a, b, c, d, right, or probably n, r as is there in the question, we'll be able to understand this perspective also. Now if we talk about factorial of n minus r minus 1, then we can write this as n minus r minus 1, which must be the largest number. And now here we require to write the next lesser number in the set of natural numbers. So as you've seen here, if we talk about factorial 7, right, the largest number here is 7. The next lesser number is going to be 7 minus 1. The next lesser number is going to be 7 minus 2, and the next number is going to be 7 minus 3, and all of this is going to continue up to 1. So here also the next number, which is the next natural number, has to be a number which is going to be subtracted, that is 1 more than the earlier number, that is r minus 1, right. So here, as we've written here 7 minus 1, next is 1 more than 1, that is 2. So here also we've got to add 1 to r minus 1. So r minus 1 plus 1 will become equal to r. So as such, the next number becomes equal to n minus r. Similarly, to get to the next lesser natural number, we will have to add 1 to r, and that will become n minus times of r plus 1, right. That is what is here, and I'm sure you will be able to get to the next one, that is, it will become equal to n minus times of r plus 2, and so on, that will go up to 1, right. So here, children, we've got the value of factorial of n minus times of r minus 1, right, and we can thus write it to be the first number times of the product of all of these numbers, and this is what has been written here. And next, children, what we can do is, as we see that the numbers from n minus r and reducing to every next natural number and moving up to 1 is actually factorial of n minus r. So that's why we've written this to be factorial n minus r, and you find that this and this matches in the numerator and in the denominator and are also in multiplication, so they get cancelled. As such, now you will just be left out with factorial n divided by factorial of n minus r, right? And that, children, is the same as what you had on the left hand side and matching. Thus we can say that the sum stands proved. So is everybody clear about this? This was a little tricky, right? But I'm sure now you must have understood. And for that matter, if you haven't understood, you have the lecture before you. You can watch it, say, 2 times more to make it more clear, right? And if still you're confused, you can get back to me. I'm always there to help, right? So make sure you study all of this, put up a practice, right? And get confident for the other sums, right? And have a nice time. Bye now.